Now that we know the simple form of the pigeonhole principle, punta naman tayo sa generalized pigeonhole principle. It states that if n objects are placed into k boxes, then there is at least one box containing at least the ceiling of n over k objects. So to prove that, gamitin ulit natin yung contradiction. We let each of the k boxes contain at most the ceiling of n over k minus 1 objects. However, note here na yung ceiling ng n over k natin is less than n over k plus 1. For example, meron tayong the ceiling of 8 over 5. Ilan ba yan? Di ba yan ay 2? Okay? That is less than yung 8 over 5 plus 1. Ano ba yung 8 over 5 plus 1? That is equal to 2.6. Okay? So, take note of this kasi gagamitin natin yan. So, since each k box contains at most ceiling of n over k minus 1, then this implies that the total number of objects is at most k times the ceiling of n over k minus 1. Pero sabi natin kanina, di ba, etong part na ito is less than etong part na to. So we can say that k times the ceiling of n over k minus 1 is less than k times n over k plus 1 minus 1. And kapag sinimplify natin yan, that is less than n plus k over k minus 1. Okay? Ginawa lang natin itong similar fraction, which is equal to n plus k minus k over k pag ginawa naman natin itong similar fraction. Observe that pwede nating tanggalin yung k tsaka k dyan, which gives us k times n over k. Again, pwede nating i-cancel to kasi magiging 1 lang yan. Therefore, that is less than n. Di ba sabi natin kanina, eto yung maximum or eto yung at most number. Less than n siya. Sabi natin, di ba, n objects yung i-place natin sa k boxes, which is a contradiction. Thus, the theorem is true. So let's have some examples. Among 100 people, at least 9 have the same birth month. So parang sinasabi kasi niyan, kung meron tayong 12 times 8, ilan ba yan? Yung 8 na ito galing dito sa 9. 9 minus 1. Kasi diba, kapag dinivide mo tong part na to, parang 8 point something. Kaya yung ceiling niya is 9. So, gagamitin natin yung 8. Yung 12 times 8 is 96. So, ibig sabihin, merong 8 people na possible na magkaka-birthday. Okay? So, 8 na tag-January, 8 na February, 8 na March, gano'n. At silang lahat ay 96. So, meron pa tayong sobrang 4. So, yung 4 na yun ngayon, sure tayo syempre na madidistribute din siya from January to December. So, ibig sabihin, at least 9 have the same birth month. Baka nagtataka kayo dito kasi sabi natin at least 9 have the same birth month. Pero sabi ko kanina, merong 8 na magkaka-birthday. Diba? Di dapat at least 8. Bakit at least 9? Well, ang sinasabi ng theorem natin, di ba sabi niya, there is at least one box containing at least the ceiling of n over k objects. Okay? So, tama nga naman, merong nag-i-exist na at least 9 yung laman niya. Kahit isa lang yon. Okay? So, pwedeng yung iba, walang laman, basta sure tayo na isa sa mga yon, sa isa sa mga month na yon, meron siyang laman na at least 9. Yun ang ibig sabihin ng ating theorem. Okay, for letter B naman, given 13 colors to be used in painting 120 houses, at least 10 houses will be of the same color. Again, parang yung kanina, meron tayong 13 times 9, which is equal to 117. So, meron pa tayong tatlong sobra. So, possible na yung 9 na bahay na yon, pare-parehas sila ng kulay. Siguro, 9 na red, 9 na blue, gano'n. Hanggang 13 na colors, whatever man na kulay yon. Okay? So, lahat-lahat yon ay 117. Ngayon, since merong tatlong sobra, sure tayo na merong at least 10 bahay na same yung color. Okay? So, eto na naman yon. Bakit at least 10? Kasi nga sabi ko kanina, sabi naman sa theorem, at least one of the box contains at least the ceiling of n over k. So, kahit na yung 120 na yon, isa lang ang kulay nila, true pa din doon sa ating theorem. Kasi nga, at least one contains at least 10. Example number 3, 5 points are drawn randomly inside a unit square. Show that there is at least 2 points with a distance less than square root of 2 over 2. So to solve this, we consider a unit square cut into 4 equal smaller squares as shown. So ito yung unit square natin, hinati natin siya sa 4. So each dyan is 1/2 tapos 1/2. Okay? Itong part na yan. So there are 4 smaller squares or pigeonholes and 5 points. Yun yung pigeons natin. So with the pigeonhole principle, at least 2 are in the same smaller square. Tama? Now, the distance between these 2 points is less than the length of the diagonal of the smaller square. Kasi yung pinakamalaki na is yung diagonal. Pero since nasa loob siya, so sure tayo na mas maliit yung distance niya kesa doon sa diagonal. Eh, ano ba yung length ng diagonal? Diba that is just equal to square root of 1/2 squared plus 1/2 squared. So, diba 1/2 ito, tapos 1/2 din to. So, ginamitan lang yan ng Pythagorean theorem para makuha mo yung length nitong diagonal. Kasi square yan originally, diba? So, pag nakuha mo yung diagonal na yan, that is actually equal to square root of 2 over 2. But, yung points natin, nasa loob niyan. Wala naman dito sa dalawang corner niya. So, sure tayo na mas maliit yung kanyang distance kesa sa square root of 2 over 2. Therefore, there is at least 2 points with a distance less than square root of 2 over 2. We also have the strong form of the pigeonhole principle. So, we let q sub 1, q sub 2, up to q sub n be positive integers. If q sub 1 plus q sub 2 plus up to q sub n minus n plus 1 objects are distributed into n boxes, then either the first box contains at least q1 objects, or the second box contains at least q2 objects, or the nth box contains at least q sub n objects. For our proof, suppose that q sub 1 plus q sub 2 plus up to q sub n minus n plus 1 objects will be distributed among n boxes. If for each I equals 1, 2, up to n, the ith box contains fewer than q sub I objects, then the total number of objects in all boxes does not exceed q sub 1 minus 1, q sub 2 minus 2, plus up to q sub n minus 1, which is equal to q sub 1 up to q sub n, the sum of that, minus n. Yung n na to galing dun sa mga minus 1 ng lahat. Pag pinagsama-sama mo, minus n na yan. Since this number is 1 less, okay, eto, 1 less siya than the number of objects distributed for some I from 1 to n, the ith box contains at least q sub I objects. Notice na pwede nating i-distribute itong part na ito among the n boxes in such a way that for no ith is it true that the ith box contains at least q sub 1 objects. Paano? Ipasok lang natin ito doon sa first box, ito sa second box, up to ito sa last box. At pag ginawa natin yun, hindi tayo makakasigurado na merong susobra. Okay? Therefore, kailangan nating magdagdag ng isa or the least number to be distributed in the n boxes for this to be true should be q sub 1 plus q sub 2 up to q sub n minus n plus 1. A basket of fruit is being arranged out of apples, bananas, and oranges. What is the smallest number of pieces of fruit that would be put in the basket to guarantee that either there are at least 8 apples, or at least 6 bananas, or at least 9 oranges? So for our solution, by the strong form of the Pigeonhole principle, 8 plus 6 plus 9 minus 3 plus 1, so yun yung sinasabi niya, di ba? Q sub 1 plus Q sub 2 plus Q sub 3 minus n plus 1, so 21. So 21 pieces of fruit will guarantee a basket of fruit with the desired properties. But 7 apples, 5 bananas, and 8 oranges, a total of 20 pieces of fruits, will not guarantee it. For the last example, 2 discs, one smaller than the other, are each divided into 200 congruent sectors. In the larger disc, 100 of the sectors are chosen arbitrarily and painted red. The other 100 sectors are painted blue. In the smaller disc, each sector is painted either red or blue with no stipulation on the number of red and blue sectors. The small disc is then placed on the larger disc so that their centers coincide. Show that it is possible to align the two discs so that the number of sectors of the small disc whose color matches the corresponding sector of the large disc is at least 100. So for our solution, observe that if the large disc is fixed in place, there are 200 possible positions for the small disc such that each sector of the small disc is contained in a sector of the large disc. Tama? So nilagay natin yung large disc natin, pinatong natin yung small disc, tapos kapag i-rotate natin yung small disc natin, di ba meron tayong 200 possible positions? So, isang ikot, 1, 2, hanggang matapos yung 200 na sectors ng small disc natin. That is 200 possible positions for the small disc. So first, let's count the number of total color matches over all of the 200 possible positions of the disc. Since the large disc has 100 sectors of each of the two colors, each sector of the small disc will match in color the corresponding sector of the large disc in exactly 100 of the 200 possible positions. So, kunwari, pag pinatong na natin ganyan, kunwari lang red yung nasa harap natin. So, alam natin yung larger disc natin, yung kalahati niya red, yung kalahati niya blue. So, ngayon, kapag minove ko siya, okay, kunwari yung red na nasa maliit, nakatapat na siya sa red na malaki. Okay? At kapag binilang natin in 200 possible positions, ilang beses na magko-coincide yung red na maliit doon sa red na malaki. Di ba 100? So yun yung sinasabi nito. Thus, the total number of color matches over all the position equals the number of sectors of the small disc multiplied by 100. And this equals 20,000. Tama? So sa isang sector ng small disc natin, di ba? Sabi ko kanina, 100 yung possible na matches niya. So ngayon, yung second na sector niya, ganun ulit, 100 ulit yun. Yung third na sector, ganun ulit, 100 ulit yun. At ilan lahat yun kung 200 yung sectors ng small disc natin. So that is 200 times 100, kaya 20,000. Therefore, the average number of color matches per position is 200,000 divided by 200 equals 100. So, there must be some position with at least 100 color matches.